In this unit, we'll be talking about the overall architecture of TiDB. The core component of TiDB database, in short, TiDB, is composed of 3 server clusters, all of which communicate with each other to form a database cluster. The subcluster components include TiDB Server Cluster, TiKV Server Cluster, and the placement driver or PD cluster. All 3 subclusters are decoupled with each other. The number of TiDB servers does not have to be equal to the number of TiKV servers and does not have to be equal to the number of PD servers. For example, you can have 2 TiDB servers, 3 PD servers, and 6 TiKV servers. The first server cluster I would like to discuss about is TiDB Server Cluster. Do not be confused between TiDB and TiDB Server Cluster. The TiDB Server Cluster is a component, a subcluster of TiDB. The TiDB subcluster, which represents SQL Layer, exposes the connection endpoint of MySQL protocol. TiDB server instances within the cluster are responsible for accepting connections from the database clients. The TiDB server cluster is stateless, and in practice, multiple instances of TiDB server can be launched, and a unified DNS name can be provided through a load balancing component such as LBS, HA proxy, or F5 big IP. If you are in the public cloud, the elastic load balancing service provided by the cloud service providers also works. Thus, client connections can be evenly distributed across multiple TiDB server instances without explicit efforts in your application. The TiDB servers do not actually store the table data. It only passes SQL statements and forwards the data request to the storage layer, which is TiKV Cluster. The second subcluster I would like to discuss about is PD, or Placement Driver Server Cluster. It is the metadata management module for the entire TiDB, which stores the real-time data distribution of each TiKV node and the overall topology configuration of TiDB. It generates the transaction ID for distributed transaction, which is based on the TSO, or timestamp oracle. TSO is a timestamp to guarantee that 2 changes happen within the database in a temporal sequential order, even though the database is in a distributed database. PD not only stores metadata, it also issues data scheduling commands to specific TiKV nodes based on data distribution that is reported in real time by TiKV nodes. PD is considered to be the brain of the entire cluster. As the cluster backed up by rough algorithm, PD need to deploy to an odd number of the nodes. It is usually recommended to deploy 3 nodes at least. As long as the majority nodes are alive, your cluster is open for read and write operations. The last subcluster, the TiKV cluster, is responsible for storing table data. For an external view, TiKV is a distributed transactional key-value NoSQL database. TiKV also uses rough algorithm for replication to ensure data consistency and disaster recovery. The load balancing of the data placement among different TiKV nodes are scheduled by PD, the brain of the cluster. I'm going to show you a simple example similar to the steps shown on the slides, so that you can have a basic understanding of how TiKV stores data. I'm going to use TiUp command line tool to launch a playground sandbox on my local machine. Once TiDB is up and running, I will use raw KV API to do simple puts, get operations to show you that TiKV is a key value store. The script itself is pretty intuitive. It calls TiUp to spin up a whole TiDB system tagged with the name Classroom. We deployed 3 TiDB instances, 3 PD instances, and 3 TiKV instances, and 1 TiFlash instance. Let's set aside TiFlash instance for now. We'll cover TiFlash later in this course. And no worries, if you don't have TiUp right now, you will have TiUp installed after lab 1 at the end of this course. So let's do it. You can see that PD is up, then TiKV and TiDB are getting up. In a real-world production environment, you can spin up these servers on different nodes. Please note that Playground is just a sandbox for testing purpose only. Okay, it's all ready by now. You can see that we use a raw client to build a connection. The endpoints we are using are from PD. We simply put and get a new key value pair. And then let's try to get a value from a non-existing key. Let's see what happens. That is what we expected, right? We can actually put key value pair into TiKV. And we can get value from key 1, but not from non-existing key 0. So, this is the first time and the last time we use raw KV interface for this course. After that, throughout this course, the only language we will use to communicate with TiDB will be SQL.